everybody, welcome back to another episode of The Guild. So this video is going to talk about equal spread offsets. So more than one pipe, you have 2, 3, maybe even 4 offsets of pipe to do. And they're all going to be 45 degrees. They're all going to be equal spread offsets. So we'll be talking about the rule of triangle as well as some other basic trigonometry functions. So stay tuned.
All right, so here we have the equal spread offset. So if you watched the other video where we just did a single pipe offset, this one is a 2-pipe offset, and we're going to talk a little bit about the rule of triangles again and add a little bit more complexity. So let's get started. So here we have 2 pipes in a vertical position, and you can see that they are equally distanced apart. So if I look in between the pipes here, the distance all the way through is equal. So whatever the measurement will be down here, it will be the same up here, and conversely or adjunctly, it will be the same distance here where the offsets are. Okay, so that's why it's called an equal spread offset. And so with the next slide, we're going to add in some more details. So you're going to see some labels here, A, B, C, D, E, and F. You'll also see this triangle here that I've made. So you'll notice that I've drawn a line from the center of this fitting straight down and a line from the center of this fitting straight over, and where they intersect I've put in a square box indicating that that's a right angle. And so essentially I've just created myself a triangle. I've also added in this marker here to tell us what the distance is between those 2 pipes. So you can see here that the triangle fits just perfectly here. And if you watch that other video, you'll remember that on a 45-degree offset in a right angle triangle, all I need to know is the distance of the travel or the offset. So in this case, what do I label the sides? It doesn't matter so much, except for the fact that I want to know what I'm talking about when I'm talking to other guys in the field, or I'm actually talking to students in a class, or here I am talking with you. So if I want to label offset travel, this is what it would look like. So the travel, again, is always the direction that the pipe is going in. So you can see here the pipe is going in this direction from bottom to top. Therefore, the travel side is bottom to top. The offset is always the distance between the 2 center lines of the same pipe. So you can see here I've labeled offset and travel. And so with that now I can go and determine what my hypotenuse is. And with that I go to this familiar formula of offset is equal to, in this case my diagram, I've just chosen my offset to be 14 inches. And so this distance from the center of this pipe over to the center of this pipe is 14 inches. So looking at the formula, now I have 14 times 1.414 gives me 19.8 inches. So the hypotenuse, or the distance between the center of this fitting and the center of this fitting, is 19.8 inches. And there's an important note to remember here, that this is center to center measurement. Out in the field we would take care of that and get rid of those fitting allowances, but for the purposes of this demonstration, and even when you're doing a question on an exam, you don't really need to worry about dealing with fitting allowances. So looking further on, I now draw a line that is parallel, if you want to call it that, or I just draw a line straight across both pipes starting at this fitting, and I draw another square here to indicate that this is another triangle. And so you're going to see the use of triangles in equal spread offsets quite a bit. And so there is a bit of terminology to remember with them, but what you need to remember mostly is just the rule of triangles. So you can see here this triangle gets formed by me drawing that line straight across. So going into the formulas now, on the right hand side, you'll see that the extension is equal to spread times 0.414. So what's the extension? Well, the extension is really the length of pipe from where this line comes across down to the center mark of this fitting here. So in essence, you could say, how much longer is this pipe, or how much further does this pipe extend than the pipe beside it? That's what you're really looking for. And so for the purposes of exams and demonstrations, again, we're not going to worry about the fitting allowance here. We could if we really wanted to get nitpicky with it, but in this demonstration, we're not going to do that. So where does the 0.414 come from? Well, that's just a trigonometry function, and in fact, it's a constant, and it's really easy for us to remember in these 45-degree offset equal spreads that the spread times 0.414 gives us the length of this extension. So what's the spread? The spread is indeed the distance between the two pipes, the center lines of the two pipes. And if you remember earlier, I said whatever the distance is in one place, it will be consistent all the way through. So we can safely assume that if we're told the distance here, it will be 12 inches or the same up here. So in essence, I can say, well, the extension is equal to 12 times 0.414, and so that's going to be 4.97, and you'll see that on the calculator as we're talking. So in the next demonstration, you're going to see here that I just actually start writing in some of my numerical values. And with that, I start working my way around the drawing. So in this case, I'm just going to tell us that this length of pipe from here to here is 36 inches. Therefore, I can find out how long the length of pipe B is by simply adding the length of my extension to the 36 inches. So the 4.97 gets added to the 36, and therefore I have 40.97 inches. And so if I continue down to the bottom of the pipe, you'll see down here we've given this value 56 inches. So the other interesting thing about equal spread offsets is that if you figure out what this triangle is, you're going to have a similar triangle down here. Now, I didn't draw it in, but it will be the same. So it will have the same length of extension as this side does. And that's one of the beauties of equal spread offsets with 45-degree angles. And so moving down here, I can just take that distance now that I figured out up here. Because it's going to be the same down here, I'm going to subtract it from this number here, because I want to know the length of this one. And just looking at it visually, you're going to know that it's shorter. So I'm going to subtract the 4.97 from my 56, and I'm going to end up with 51.03 inches. And so finally, what we end up with is a bunch of numerical values for all of these pieces of pipes. Now, you'll also notice that these two offsets in the equal spread offsets are exactly the same. So that makes it really easy for us when we start looking at multiple pipe offsets. The offsets, or the hypotenuse of each one of these, will all be the same length. And that makes it really nice for us when we're doing some prefab out in the field, or I'm doing a cut sheet or a cut list that I'm going to send to a different part of the job site, or even off job site. I'm going to mail it into my shop, and they'll cut it for me and get it ready for me in the shop. I would just label those pipes as they are, and then tell them what the size is, or the length end to end, that I would need. And so in this case, you can see that this pipe here is 40.97. So if I really wanted to take that to the next level, or take it to somewhere where somebody can work with a tape measure per se, I'm going to say that that's 40 7/8 of an inch. And then all the way down, you can see here 19 3/4. Now, looking at this 0.8, you're going to say, but Tim, that's not 0.75. It's a little higher than 3/4. You're saying it's 3/4 here. Yes, that's exactly what I'm saying. You're going to have some rounding happening here. And in reality, out in the field, these numbers, you can cut them exactly and have them all fit, still fit fine, because you're gonna massage this as we go. So I wouldn't get too hung up on the fact that this isn't 0.75, is a little higher, and then why did I go to 3/4? It's just a rounding technique that we do. So again, one more thing to always point out, these measurements do not include their fitting allowances. So indeed, if I really wanted to know what the size of this pipe was, I would go back to find out what the size of fitting I have, what the fitting allowance is, multiply it by 2 because I have 2 fittings, and then subtract that from the 19.8 to get the true end-to-end piece here. And if this is welded, I'm going to have to worry about gaps. If it's screwed, then I'm going to have to worry about fitting allowances between the thread engagement and the throw or the center line of the other side of the fitting. So that's how we deal with equal spread offsets.
Hey everybody, thanks for tuning in and watching this video. I hope it was valuable to you. If it was, press the like button or press the subscribe button so that way you get all my new videos as soon as they come out. Also, pass the word along that these videos are out there on YouTube. It'd be really awesome if other apprentices and new journeymen knew that these videos were there, just to give them a helping hand. And also, remember that there are other videos and other playlists like my productivity skills, essential skills, trade skills, and exam skills. Those things that will help you get ready for that IP exam. So my email address is in the show notes. So is my other social media connections. So why don't you just go ahead and get in touch with me. It'd be awesome to hear from you and to know if there's anything else that I can help you out with. Other than that, stay hungry, stay classy, make sure that you stay professional, and have a great day.